We're going to begin a lesson on solving right triangles, but we're going to begin with some calculator practice and learn how to enter those angles that are not on the unit circle into our calculator. The first thing you need to check is your calculator in the correct mode. And we're going to put our calculators into degree mode. And the way you do this, if you have a Texas Instrument calculator, is you are going to press the button that actually says mode, M-O-D-E. And when you see this button, there will be some options on the third line down where it says radian or degree. Now the one that's highlighted is the mode that it's in. We want it to highlight degree, so arrow over to degree and highlight that, and then you will press enter, and then your calculator will compute your trig functions in degree mode. So we're going to begin with cosine of 32.5 degrees, and we're going to round to 4 decimal places. And when you enter this in, you get 0.8434. And we'll do our sine, and that's 0.9806. And if you look at your calculator, there is no secant button, but secant is the reciprocal of cosine. So you will enter 1 divided by cosine, and then enter 34.7, and what you get is 1.2163. So for our first example, I want to find theta when cosine theta is 0.8330. And we would have found this in a right triangle by using adjacent over hypotenuse, but we need to know what the angle is. So a way to undo an action is to use an inverse. So we are going to inverse both sides. Well, cosine inverse just leaves theta. And we'll have cosine inverse, and this little -1 means inverse, 0.8330. And when you enter that into your calculator, you're going to do second cosine, and it gives you the inverse prompt, and then 0.8330, and that will actually solve for your theta. And we're going to round to 1 decimal place, which gives you 33.6 degrees. Now you try it with sine, pause the video, and when you're done, come back and check your answer. And when you check your answer, you should have 60.5 degrees. So solving a right triangle means a few things, and I'm going to start with the main two. The first thing that it means is that you're going to find values for all angles and all sides, and the next few steps are tips on how to accomplish that. To solve some of the sides, you may want to use the Pythagorean theorem. For some of the angles, you will need to use SOHCAHTOA and possibly to use the inverse to solve for your angle. It is important to label your triangle. The angles and their opposite sides use the same letters, but the angle uses a capital letter and the side uses lowercase letters. And then you're going to want to keep track of if you found all of your sides and angles by using a list or making a list. You can also label a triangle. So let's begin with this triangle. And what I like to do is make a list and just put a triangle off to the side for reference. And I like to begin with writing into my list what I already know. Now, we also know that the right angle is 90, and that is always angle C. So you can label your triangle. I'm going to circle on my triangle the sides that I already know, sides and angles. And the easiest thing to begin with is to find angle B. Now on a right triangle, the other two angles, not the right angle, add up to be 90. So I just need to solve for angle B by subtracting angle A. And that gives me 55.4 degrees. I'm going to write this up here on my list. And then I'm going to circle that angle to show that I found it. Now side B requires SOHCAHTOA. Now I like to use what's given, and I was given A, and I was given angle A also. So SOHCAHTOA has to do with the relationship of the angles to the sides. Now angle A is opposite of side A, and those are the two things I know. And angle A is adjacent to side B, and I need side B. So opposite and adjacent tell me that I'm going to use tangent. So tangent of 34.6 equals the A over B, so that's 120 over B. Now I'm going to multiply both sides by B, and then divide both sides. And I'm going to divide both sides by my tangent, so that gives me 120 over tangent 34.6. You can put this all onto your calculator at the same time, and it avoids a rounding error, and you'll get 173.9 for your side. Now the last thing is to solve for side C, and this is a right triangle, so we can use the Pythagorean theorem. So my A squared means I'm going to do 120 squared, and then plus 173.9 squared, and that's equal to C squared. Put this into your calculator all at the same time. You get 44,641.21 equals C squared, and then take the square root of that, and that gives you a side length of 211.3 equals C. And I'm going to write this up here on my list, and that ends the work for this one once I have all sides and all angles labeled. Now looking at this triangle, I went ahead and filled in my the three pieces that I already knew. I knew two sides and an angle. Remember, sides are always labeled with lowercase letters. And I only need to know one more side, so I'm going to use the Pythagorean theorem for that. So I have A squared, so 19.2 squared plus B squared equals 47.5 squared. And when I square 47.5 and subtract 19.2 squared, I get 87.61. And you need to take the square root of both sides for 43.4. Now I'm going to circle the ones I already knew. I knew this one, I knew this one, I found this one, and I know that. So I need to find one of my angles, so I'm just going to go down my list and begin with angle A. And with angle A, I was given my opposite A and the hypotenuse, so I'm going to use sine. You can use other ones, but I always like to use the sides that I was given in the beginning. And I'm just going to substitute that into my calculator, and what I get, and I'm going to round this to 4 decimal places, is 0.4042. Now my A is inside the sine, so I'm going to have to inverse both sides. So I'll do sine inverse, which is second sine on your calculator. And this gives me an angle of 23.8. Now if you use another angle, another trig function, you may end up with something just slightly different from this, but that's fine. It'll still be fine. Then the last step to find angle B is to subtract angle A from 90. And that gives you 66.2 degrees. And then we have solved this one. Okay, so we're going to have one more of these triangles. I'm going to fill in what I know. And I see that I only know one side, so I'm going to begin with my angles. And I will begin by subtracting angle A from 90 for my angle B. I get 68.9. These are all degrees, so we need to put our little degree marks. Alright, so we've got A down, B down, C down, and we know the hypotenuse. So the fact that I know the hypotenuse makes me think that I'm going to use sine and cosine. So I need to find side A. And I know angle A, so I'm going to use angle A. Side A is opposite angle A, so that says to me we're going to use the sine. So it'll be sine of 21.1 equals our opposite over our hypotenuse, and hypotenuse is 40.5. And multiply both sides by 40.5. Now be careful not to multiply 40.5 by your angle. Your angle can't change, so don't make the angle change. And so we can multiply this all into our calculator at the same time, and this gives us 14.6 equals A. And then the last thing, for angle B, we could use SOHCAHTOA, we could use cosine and find angle B, or we can just use the Pythagorean theorem. And a lot of people prefer to do that. So we'll substitute this into the Pythagorean theorem. Square your sides before you subtract. And when you do this, you end up with 1,427.09. And then we will take the square root of that and get our last side. And write it on our list. And then we have solved our triangle. Now we're going to do some problem solving, and we're going to begin with making a large Z. Now, angle of elevation. Elevation means that something is up higher, and so you need to look up. So this is the angle where we have to look up. So here's theta. And this will be angle of elevation. Now, the other angle, you have to look down. This line right here, this will be a line of sight. The top line is a line of sight. So here is theta, and this is angle of depression. They both begin with the letter D, so it might help remember. So for our word problems, these always help if we would actually draw a picture. So we have a vertical chimney, like on a house right here. This is our chimney. And it casts a shadow. Now shadows are only on the ground. So the shadow stretches out right here, and it's 40.2 meters. And this is the angle elevation of the sun is 35 degrees. So what this means is from where we're looking at the end of the shadow up towards the sun, this will be 35 degrees. And let's put a sun in here. So right here, here's our sun. And I think our sun needs to get a little happy. So there's a happy sun. Okay, so what we're looking for is how tall is the chimney. So here's X, and this is a right triangle. So we just have to figure out how to solve for this one. And we're not solving the whole triangle, we're just solving part of it. Now X is opposite of 35, and the shadow is adjacent to angle 35. So it looks like a tangent problem to me, so we're going to do tangent 35 equals opposite X over adjacent 40.2. And to solve for x, we will just multiply both sides by 40.2. And you put that in your calculator all together, same time, round to the 1 decimal place. So 28.1 meters is how tall my chimney is. So as an airplane approaches a landing strip, the angle of depression of the control tower from the plane 2 minutes before landing is 3.6 degrees. The 2 minutes doesn't really affect the problem. That does give us perspective. So I'm going to put a little airplane right here. It looks more like a fish. Yeah, kind of a shark, but we'll call it an airplane. There's the pilot. And now the angle of depression is from the airplane. So here's my line of sight, the top. And it says that the angle of depression, and the angle of depression is where we're looking down, is 3.6 degrees. So it's not that much. So 3.6. So to the control tower. So the control tower, here's my control tower. And we want to know how high is the plane above the control tower. Now this is a vertical height. So it's a vertical height. So we're looking for this. And this is a right angle. So we also know that the distance between the plane and the control tower is 4.8. Now that's our hypotenuse. So the hypotenuse can either be adjacent or opposite. It is the hypotenuse. Now x is opposite. So we're going to use sine. So sine 3.6 equals opposite over my hypotenuse. Multiply both sides by 4.8. And when we multiply that all out, we figure out that we are 0.301 kilometers above the control tower.